So, well, in this situation, we are given two functions which are sketched on the same system of axes. So we have the function of f, which is defined as ax squared plus bx plus c, and the function of g, which is defined as g of x equals mx plus c. And here right away, we notice that both of these functions have the same constant c, which is actually the y-intercept of both of them. And since the y-intercept is the same, it's also visible on the graph because it's where both of them intersect. So they intersect at the point, I want to say their point of intersection is actually the y-intercept. How awesome is that? But this is what they tell us. They say, if it is given that f of x times g of x is less than 0 for all values of x when x is less than -3, but greater than -6, or where x is strictly greater than 2, determine the value of a in terms of m, and please show all your workings, and this is for 5 marks. Now, what is the meaning of f of x times g of x is less than 0? Well, this means quite simply, if you take a y value on the function of f and you multiply it by the y value on the function of g, this result has to be negative. But in order for the product of two y values to be negative, that's if and only if one of the y values is positive and the other y value is negative. So let's give it a good look and see what is really happening in this case. So here we need to divide these two graphs into intervals, okay? Now, how do we choose the intervals? Well, we are going to choose either where one function is intersecting the x-axis or where both of them are having an x-intercept so that we can identify where one function is above the x-axis. In other words, its y values are positive, and the other one is below the x-axis where the y values are negative. So we go to the x-intercept of the blue function and we draw the first interval. We go to the x-intercept of the pink function and draw the second interval. And then we go to the point of intersection of these two functions. And once again, we draw a vertical line which separates the intervals, right? And the other vertical line is supposed to be on the y-axis, okay? And then another vertical line is going to be on the x-intercept of the pink function. So now we need to identify where one is positive and the other is negative. Okay, fine. So if we look at this interval from -infinity up until this x value there, then what do we see? Well, here we can see that the blue function is negative, and this function is also negative. Remember, guys, even though it seems like it's going down, but in the actual sense, this parabola is doing something like this. So in terms of x values, it comes from -infinity. Remember that. So it means from -infinity up until a certain value there, both of these functions are negative. And negative times negative is a positive. So it's not the interval we are looking for. Then we focus on the next interval. So here we can see that the function of g is above the x-axis, but the function of f is below the x-axis. So this means If you multiply something that is positive with something that is negative, you definitely get a negative result. Okay, this is the interval we are looking for. And then we move. So if we focus on this interval, well, here we can see that both y values are positive. So the product of two positive numbers will be positive. As well as in this interval, both y values are positive. So we cancel these two intervals out. And then we move. If we focus on this interval, we can see that both y values are positive. So we quickly cancel it out. But if we look at this interval from 2 to infinity, in fact, we don't know as of now that it's 2, right? But if we look at this interval, we can see that the function of g is positive because it's continuous, and the function of f is negative. And positive times negative is undoubtedly negative. So now it's time to fill in the values of x. Remember they said to us, f of x times g of x is going to give us something that is negative when x is between -3 and -6. In other words, in this interval, the value of x here is going to be -3, and the value of x there is going to be -6. So these are actually the x-intercepts of the blue function and the pink function. That's the most realization that we make, or the most important realization. And once again, we know that the product is negative when x is greater than 2. So since we can see that here we are dealing with positive values of x, then it stands to reason that the x value here is going to be 2. And this x value is actually the x-intercept of this parabolic function. Okay, fine. So now we have everything that we need in order to answer this question. Remember that the formula for f of x is actually the standard form, and the formula for g of x is also the standard form. But what we are trying to do here is to express a in terms of m. So what's the easiest thing we can do? Well, we can just go to the function of g, and here we can see that we are only given 1 point on the blue function, and that's the x-intercept of the blue function. So this means we need to use the fact that on the function of g, when x is -6, y is going to be 0. In other words, y is going to be 0 every time when x is -6. So this means every time you see c, you actually see positive 6m. Oh, what is the meaning of that? It means if you actually go to the function of f and say every time you see c, well, you actually see 6m. It's the truth. So this means the function of f is now going to be defined as ax squared plus bx plus c, which is now 6m. Now, looking at the function of f, we can see that we have two x-intercepts. So firstly, we are going to use the fact that when x is 3, y